Well, good evening, everyone. It's nice to see everyone that made it out this evening. I'd like to welcome you to the lecture this evening. In an age of science, is there a need for God? Something that, for me personally, is a good question worth pondering and looking at, given my background in the engineering field, and I know that others in science, medicine, and other fields like that perhaps find this a quite engaging topic as well. But we welcome you here this evening. And so as an introduction to the speaker this evening, Burkhard Schmidt. Dr. Burkhard Schmidt is a principal physicist at CERN, which is a research institution in Switzerland. So he is, I guess, technically resident of France, but for all intents and purposes, from the Switzerland area, Geneva area. We're pleased to have him here this evening. He was in town for some other lectures and other events, and we were pleased to have him here this evening. I look forward to his discussion on this topic. So without further ado, I'll leave it to Dr. Schmidt.
Thank you. Yeah, thank you for the warm welcome, and it's nice to be here and share with you a little bit on the topic. In an age of science, is there still a need for God? So on the title slide, I show you here a view of the Geneva area. The Geneva itself is here. It's not that large, but there it is, the Geneva Lake, the beautiful Alps behind. And then you look here, marked in red, at the LHC tunnel. And here you look inside the tunnel, and as we go on with the lecture, I will tell you a little bit more about this. Yeah. Now, this is a question, and we look at it in the light of research and discoveries we have been doing at CERN, and about some of them you have heard also here. And as the results are mentioned, oftentimes the idea is given, well, no, we have understood so much, so we don't need God any longer, right? And that is why we want to address the question, and I will try to explain you a little more, what we can conclude from the research we are doing in particle physics. So yes, I am working there since now nearly 30 years, and I am a passionate scientist, and at the same time I'm also a believer, a Christian, and I want to say straight away from the beginning that it's nice to do research as a Christian and to see really that things nicely come together. And I hope I will be able to convince you a little bit about this also in the course of the lecture tonight. So, the question is, indeed, can you be a scientist and believe in God? And some people say, yeah, well, faith in God is old-fashioned. It belongs to the days when people didn't really understand the universe, and therefore they gave oftentimes a simple answer, we don't understand it, and therefore God did it. Yeah, that has been a statement often made, and we want to look at it a bit more carefully. Before doing so, in relation to the title of the slide, can you be a scientist and believe in God? What about Nobel Prize winners in physics? And it's interesting that, yes, if you look at Nobel Prize winners, they are those who have been declared agnostics, like, for example, Peter Higgs, who I met also personally after he got the Nobel Prize and he came to CERN. And other people have been really convinced Christians, like William Phillips, who got the prize already more than 20 years ago. So what is dividing these people is not really their science. They have both, and all of them, been passionate scientists, but it's really their worldview. And the differences are that some are theists, or Christians even, and others are atheists, or in the softer form, agnostics, who say, well, we can't know really. Yeah. But if you look at it more carefully, about 65%, so 2/3 of the Nobel Prize winners in the 20th century at least confess that Christianity has been their religion. And of course, then you have many variants there, but it's, I think, interesting to note. Okay, now going a little bit further in time, what about the founding fathers of science? And their names like Johannes Kepler, Blaise Pascal, Isaac Newton, Michael Faraday, James Clerk Maxwell, and others come to mind. And they were all convinced believers in God. Everyone who has done physics came along these famous names, and it's interesting to note that they have been really Christians. Johannes Kepler made this statement: the chief aim of all investigations of the external world should be to discover the rational order which has been imposed on it by God and which is revealed to us in the language of mathematics. And I would also like to say a bit more later on about this, namely that we formulate things in physics using the language of mathematics. That means we can really describe things very precisely in the exact sciences. Now, again, the question here, can you be a scientist and believe in God? Many people bring up the case of Galileo and say, well, he was persecuted by the church, wasn't he? Now, this is a superficial statement, and you have to look a little more carefully at the facts here. Galileo was a firm believer in God, and he was vigorously opposed by secular philosophers who were arguing with him, and they were really enraged by the criticism of Galileo of Aristotle and the Aristotelian view on, in particular, the solar system and more generally. Now, for a long time, Pope Urban VIII was a supporter of Galileo, but he was not always diplomatic, Galileo, and he managed to offend him to a point that the Roman Catholic Church muzzled Galileo, and then of course the statement was made that he was persecuted by the church, but that is not really true. So I think one has to look carefully at the facts and keep in mind that it was really an issue with the philosophers of that time and the fact that Galileo challenged their worldview. Let's ask this question now: is science the only way to truth? And I would like to use an illustration here which is easy for everyone to understand. Now, what is it? Well, I mean, this here is maybe not so easy to see, but it's a chocolate cake, as we make them in Europe and as my wife is making them. They are really tasty, I can tell you. Now, what is it made of? Well, if you ask a natural scientist, like a biochemist or a physicist or a mathematician, they can cope with questions about the nature and structure of the cake and give lots of answers about it, which are maybe not the most important ones, but still they will do so. But when it comes to the question, why was it made? They will fail to give you an answer. They don't know. And if I ask you even the question, why was it made? You won't be able to give me an answer. I have to tell you why it was made. It was at the occasion of the 18th birthday of my daughter. That is why my wife made this cake, and then you understand a little bit also about the purpose of it, which you can guess anyway because it's something nice to eat. What I want to point out here, and it's a very simple illustration, but it helps us to understand the concept. That is that science has its limitations to answer the questions we have at the bottom of this slide. Yeah, this is something we have to keep in mind. And yet, the questions and the answers, although they are not scientific, they are nevertheless rational. That means in accord with reason. If I tell you why it was made and for which purpose, These are perfectly rational questions and answers, but they are not necessarily scientific. So let's see the limits which are there in relation to scientific research. Okay. Why do some people think then one has to choose between science and God, either or? Where does it come from? Well, it comes about confusion about the nature of God. Who is God? And this picks up something I said a little earlier, namely that many people think when hearing about God, about what we call sometimes, and my friend John Lennox does it often in his books, referring to the God of the gaps, right? That is what people say. A God we invent as an explanation for the blanks in our understanding. I can't explain it, therefore God did it. Yeah? You have a thunder, and then you talk about the God of thunder because you can't, at least people thousands of years ago couldn't explain it. So they said, well, it's a God of thunder. We don't understand, God did it, and that's it. These were the type of gods the ancient Greeks believed in. And one has to be very clear, these type of gods were really a creation of man. Man invented them in order to fill the blanks in the understanding. And of course, these type of gods are disappearing as we progress in our understanding. Now, what I want to point out that the God of the Bible, about whom I wish to speak also tonight, is very different. He is not the God of the gaps and the God of the things we don't understand, but also of the things we do understand. Yeah? And therefore we could say he is the God of the whole show, not just what we don't understand, but of everything. And I would like to explain it a bit better also in the following. That means we need really God in order to be able to understand and explain things. So, when Newton discovered the law of gravitation, of gravity, he didn't say, now we have gravity, we don't need God any longer, but he expressed the hope that thinking persons would believe in a deity. His belief in God was a strong motivation in order to look for law and order in the universe, because he believed in a lawgiver. So, what we see is that science does not compete with God as an explanation. There's no competition here. Science gives a different kind of explanation. We do science, we can describe things, and I come back to this, but it's not in competition with God himself. Again, the question I asked earlier, why do some people think one has to choose between science and God? Well, there's also a confusion about the nature of scientific explanation. It's not just confusion about who is God, but confusion about the scientific explanations. And what does, for example, the law of gravity explain? It doesn't explain really what gravity is. Actually, we are still puzzled. We don't know exactly. We make progress. We understood, for example, there is something like gravitational waves. Whether a particle like a graviton exists, we don't know yet. We don't know really what it is, but it explains the law of gravity, how gravity operates. But it's not a complete explanation. And that is leading us to the statement here that the laws of nature describe the universe. A famous physicist, Richard Feynman, said the following: to find a rule like the inverse square law of gravitation is some sort of a miracle. It is not understood at all, but it leads to the possibility of prediction. That means it tells you what you would expect to happen in an experiment you have not yet done. You can use a law and you can make a prediction. Now people, I want to point out, like Richard Feynman, he was not a confessing Christian or so, but just his rational thinking led him to such a conclusion. And And I think that's important because you see they were somehow honest and telling really what they have understood. So, the laws of nature, like the law of gravity, they do not create the universe. And I put it like that because Stephen Hawking thought differently. I want to be careful. You know, he passed away a couple of years ago. He was very sick with his Lou Gehrig's disease. At the end, it was more difficult for him also to communicate. But in his book, The Great Design, he makes statements like the following: because there is a law of gravity, the universe can and will create itself from nothing. This statement is really not making sense because he's confusing a few things here. He's not seeing that laws are descriptive, but he make them somehow creative themselves. And he said it was only necessary for the blue touch paper to be lit to set the universe going. That's an interesting statement because phrasing it like that, of course, immediately raises the question, then who then lit the blue touch paper? If not God, yeah. But when he talks about nothing, it's not really nothing, but already very special conditions are there from the very beginning. And then, yes, someone has just to set the universe going. Okay, let's move on. The question is then, where do the laws of nature come from? If they are there from the beginning, where do they come from? And their great scientists are really puzzled. Alan Bluth, for example, from MIT said, I would be glad if I could answer this, yeah? But we are really, as a scientists, not able to answer this, where the laws of nature come from. Eugene Wigner, also Nobel laureate in physics, wrote, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Interesting. And if we take it further, we come to the conclusion that naturalism offers no explanation of why human minds can do mathematics, understand nature, and why nature without necessity obeys these mathematical laws. And you see that if you look at it like that, it's actually much more questionable. What are the foundations of naturalism? Because you really, are in relation to the fundamental basics, of being able to do research, you are not really consistent. So the laws of nature are descriptive and predictive, but not creative. And physical law is not an agent. And it's important to distinguish the levels of explanation, as I said earlier, physical law on one hand and personal agency on the other side. And therefore you have to say it like that, God as a personal agent on one hand, and on the other side you have physical law which can describe things. So the God in whom great scientists like Galileo, Kepler, Newton and Maxwell believed was not the embodiment of the laws of nature, but even much greater than that. Now, coming to the question about faith, is it only something for religious people? And it's interesting to listen to what Einstein had to say about this. I just read what is underlined here. He pointed out, to this there also belongs the faith in the possibility that the regulations valid for the world of existence are rational, that is, comprehensible for reason. I cannot conceive a genuine man of science without that profound faith. So he believed really in the fact that the universe is intelligible, that we can understand things. And he believed really that it is governed by the laws of mathematics and physics, and therefore carried on the work he was doing. The situation may be expressed by an image. Science without religion, he said, is lame. Religion without science is blind. Another physicist, John Polkinghorne from Cambridge, said science does not explain the mathematical intelligibility of the physical world, for it is part of science's founding faith that this is so. That is simply what you assume, this mathematical intelligibility of the physical world. To deny the need of faith undermines rationality. We need to do science. And that is related to what I said also earlier, because indeed naturalism is doing so, undermining this. Do atheists have faith? And then what is faith really about which they speak? Now, Richard Dawkins, the famous atheistic evolutionary biologist from Oxford, says atheists do not have faith. On the other hand, he also speaks about his belief system. It's interesting to have the terms faith on one hand denied and still speaking about a belief system. Scientific belief is based on publicly checkable evidence. Religious belief not only lacks evidence, its independence of evidence is its joy shouted from the rooftops. And that, of course, leads to the question, is biblical faith really blind faith, or is it evidence-based? Now, if we just look at what the Bible has to say in Romans 1, it states, the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and divinity. So there is evidence you see in the universe about the eternal power and divinity of God. And it can be understood, so it's really accessible to our intellect. And I would also like to quote from John's Gospel. Now, Jesus did many other signs in the presence of the disciples, which are not written in this book, but these are written that you may believe that Jesus is the Christ, the Son of God. And it's very interesting, this statement, because it refers to what is written in the Gospel, what is reported there also about the miracles which Jesus did, and they are reported that based on the evidence written down, people may believe. Okay, biblical faith is not blind, it is based on evidence. Now, where does the evidence lead? And here I would like to quote someone who has been for more than 50 years a very stern atheist, Anthony Flew, and after 50 years he renounced his naturalistic faith in 2004, and he said that his whole life has been guided by the principle of Plato Socrates, who said, follow the evidence wherever it leads. That is what Socrates suggested to Plato. And that is what also Anthony Flew did. And then he said at some point, in relation to questions he had, a superintelligence is the only good explanation for the origin of life and the complexity of nature. Simply saw that naturalistic explanations fail to give the answers. So he was ready to go beyond the narrowly defined scientific explanations in terms of natural processes, and this does not mean that other explanations are not rational. It just goes beyond what can be explained simply scientifically. And in relation to giving rational explanations, it's also good to remind Christians what is written in 1 Peter, that we are encouraged and prepared to give an intelligent defense of what we believe and of the hope which we have, because it is possible really to explain things in a proper way. And we should do so. Now, are we ready to challenge our worldview? And here, a rather long quotation, I don't read it in detail, but you might have heard about Richard Lewontin, a famous genetist from Harvard, who made this statement, and I read what is underlined: we take the side of science in spite of the patent absurdity of some of its constructs. And later on we have a prior commitment to materialism. And then we are forced by our a priori adherence to material causes to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. It's a very clear commitment to materialism, and still, I want to acknowledge, it's a very honest statement, although it's not really rational. If you have this a priori commitment to materialism, it's rather an expression of an irrational prejudice. So, leaving a little more the philosophical side of the presentation, I would like to get a bit more into the physics research we are doing in order to confirm a bit the statements I made earlier. Questions to material, but before I do so, I still really would like still to give you a few questions to materialism, which have been formulated by David Berlinski, a secular Jew, and this you find in his book, The Devil's Delusion, somewhat an answer to the God delusion of Richard Dawkins. And he puts the following set of questions. Has anyone provided a proof of God's inexistence? Not even close. Has quantum cosmology explained the emergence of the universe, or why is it here? Not even close. Have the sciences explained why our universe seems to be fine-tuned to allow for the existence of life? Not even close. Are physicists and biologists willing to believe in anything so long as it is not religious thought? Close enough. Has rationalism and moral thought provided us with an understanding of what is good, what is right, what is moral? Not close enough. Has secularism in the terrible 20th century been a force for good? Not even close to being close. Is there a narrow and oppressive orthodoxy of thought and opinion within the sciences? Close enough. Does anything in the sciences or in the philosophy justify the claim that religious belief is irrational? Not even in the ballpark. And finally, is scientific atheism a frivolous exercise in intellectual contempt? Dead on. It's very strongly formulated by, I repeat, a secular person. Now, coming now to the second part, big questions that people have always asked. Here are some of them. Question in relation to origin. Where did all this come from? Why is there something rather than nothing? Why do we exist? Did the universe need a creator? Where do the laws of nature come from? And to these questions, science has an input to give, to answer the questions, but by no means the only one, and maybe also not the most important one. These are the questions of origin, and then we ask, of course, what is our understanding about the origin of the universe, if we look at it now from what we could gather from scientific understanding. Now, this is showing just what we understand of the universe so far. It is about 13.8 billion years old, beginning with the creation event, often called Big Bang by scientists. I prefer to refer to it as a creation event. And then we can, of course, look at the universe, look back in the sky at stars and galaxies and so forth. We can look back up to about a time when the universe was 380,000 years old, because before that time the universe was opaque, it was not transparent. Only afterwards light decoupled from matter, and then only you can see through it. You can't look through this, what you see here on the very left hand side. The universe cooled down with time. Now the temperature is about 2.7 Kelvin. And what we are doing at CERN, as we do research, we are able to study the properties of fundamental particles and forces between them at energy densities as they existed in the first fraction of a second after the creation of the universe. So really a few picoseconds the universe was old, and that is already the energy density at which we can study how fundamental particles interact with each other. Now, looking a little more carefully at this, one can learn a lot. Actually, the image you see here on the left-hand side is similar to what you see here as well. Yeah, up to that point, you can look, and with better instruments, people could get a much higher resolution. There you see what has been observed with COBE, then with WMAP, and finally with the Planck satellite. And you can analyze very well the spectrum of the microwave background, and that is shown on the right hand side, and that you can analyze as it is shown on the right hand side, and from that you can reach a very interesting conclusion, which is shown here, namely that 95% of the universe are made of what we call dark energy and dark matter, and only 5% are made of atoms and things which we can study, which we see around us, which are really accessible to our research at present. We would like to understand the rest better, but let's be clear, we understand properly at best only 5% so far. So therefore, of course, many things have to be understood better. And here you see on the right hand side what we do understand. Our standard model in particle physics tells us, okay, our universe is made of quarks and leptons, and they are forces and they are carrier particles, which are marked here on the right hand side. In the center you have the Higgs boson, which is mentioned, and I'll come back to this in a moment. But ordinary matter, as we see it, is actually only made of the quarks encircled in red there, up and down quarks, which are the constituents of protons and neutrons and all the material we see around us. And then you have the electron there, and the other particles are actually unstable and they decay. But we can produce them and study them to some extent. So, the question is, for example, what is the origin of particle masses? And we have some clue on this. We understand things in that relation better. We want to understand better what is really dark matter and dark energy. So what is the 95%, which is not yet clear, and their research is ongoing, of course. And also the question, why is there so little antimatter in the universe? Why is our universe dominated by matter? Where is the antimatter gone? Something we try to understand in particular in the experiment on which I am working, but this is another question. And in relation to what dark matter and dark energy is, many things have been proposed, but many models also had to be set aside because they could be ruled out by the research we have been doing, or at least limits could be put on the existence of certain particles. But anyway, this is why the LHC was built, in order to find an answer to these questions. Now here you see again the tunnel, marked here in white with the other accelerators which are used to inject into the LHC. We have this tunnel which is 27 kilometers in circumference, and then in 4 different places we have experiments which are shown here, which are built in caverns in the underground, and there we can study the collisions of protons and lead, and really do this at an energy scale of TeV. That means tera-electron volt. That means you accelerate particles to the speed of light, and then they get heavier and heavier because you pump always more energy in them. Then you bring them to collision, and then you can study the new particles which are produced. Here are a few numbers for the accelerator, which are quite impressive for those who are not working in the field, because despite the fact that the tunnel has 27 kilometers circumference, in 1 second the particles make 11,000 turns, because they go with the speed of light, nearly 99.999%. Yeah? And then we bring them to collision, and we have 40 million collisions per second. Okay, and these we can then record in the detectors. The beam size is very small, 16 micrometers. The energy, however, is large because we pump so much energy into the protons, 350 megajoules. That's like an aircraft carrier at 12 knots. And the magnets, in order to operate, have to be cooled down to nearly absolute zero, 1.9 Kelvin. So it's colder there than outer space. I showed you outer space is 2.7 Kelvin. Here we go down to 1.9. The detectors are quite large. CMS has a weight of 13,000 tons. That's more than the iron in the Eiffel Tower in Paris. In another experiment, Atlas, they have 3,000 kilometers of cables in order to transfer the signals to the control room. And in terms of data we accumulate, it's increasing actually, but in the past it was 10 petabyte of data per year per experiment. And 10 petabyte means 20 million DVDs piled up of data that is 20 kilometers in each experiment every year. And this we are analyzing, which is a nice challenge. Okay. Now, I show you one of the experiments on which I have been working and still work on, the LHCb detector, which is the smallest of the experiments. Here you had first a view in the cavern. Here you see a schematic view of the experiment overlaid. Here you see then an interaction in the place where the interaction takes place, and how it looks like as particles cross the detector. This happens 40 million times per second, and you record the information, and then you reconstruct the event, and then you analyze it. Now, interesting measurements have been made, interesting discoveries have been made, in particular in relation to the origin of particle mass. So in 1964, these 3 men proposed a mechanism which is now normally referred to as the Higgs mechanism, which stated that particles acquire mass proportional to the strength of the interaction with an energy field, which is now called the Higgs field, which permeates the entire universe. And then as they interact with that field, they acquire mass, and it's interesting to see that's really fully proportional. Now, the masses are very different of particles. The heaviest we know is a top quark, which is as heavy as a gold atom. And on the other hand, you have an electron which is so much lighter, 30,000, 35,000 times. Why is it so? Well, it has to do with the coupling to the Higgs field, and that could be confirmed to a very large extent. The excitations of this field manifest themselves in particles, and this particle is then called the Higgs boson, which has been discovered at the LHC in 2012 after 40 years of searches at accelerators on both sides of the Atlantic. Now, I mention this also because in popular media outside, I want to insist on it, the scientific community, the Higgs boson is sometimes referred to as God's particle. Whenever I travel, oftentimes people ask me, have you found the God's particle? Yeah. And this expression is pretty inappropriate, and this for several reasons, but one of them is that it cannot really explain the ultimate origin of the universe. It's just helping us to understand why particle masses are different. So this mechanism has been proposed by these gentlemen, Brown, England and Higgs. It has been confirmed through measurements we made at CERN, but neither the proposal of the mechanism, not really the confirmation that it is there, is explaining why it is there, who invented it, who put it there into the universe, right? And therefore, to say that now we have found the particle, now we don't need God any longer, is very superficial and not really looking carefully enough at what can be really explained through it. Now, just to show you one result briefly, what did we observe? Well, we observed indeed a resonance, which is nicely shown here. And for example, we observe it if you look at decays where you have simply two photons in the detector, as you see here on the bottom. In the CMS detector, you see these two green lines, which are really the energy depositions due to the photons in the calorimeters. And you can nicely see that there is this bump, which is really this resonance, which we now understand well as a Higgs boson. And you have other decay modes as shown there, where this decays in another way, but what is marked there in blue is again this resonance, which has been nicely seen. So the particle is indeed the Higgs boson, and what we have are somehow fingerprints which confirm that. Here you see other particles, so it's a bit difficult. I get a bit easier immediately afterwards again, but here you see that the coupling to this particle is indeed proportional to the mass of the particle. If the particle is very heavy, the coupling is strong. If the particle is light, the coupling is much less strong. And this nicely confirms that what has been seen is in full agreement with this Higgs boson. It's also a particle which has spin zero. That means the intrinsic angular momentum. That has also been nicely confirmed. So there's no doubt in the scientific community that what has been seen is this Higgs boson, and now we just try to understand it better. This particle is the final piece, so to say, in the standard model. But I like very much what was shown in the context of the Nobel Prize in 2013 for Peter Higgs and François Englert. They show this puzzle, and this puzzle is made up of all the particles which we know, which form the standard model of particle physics. But putting it like that, people already show clearly it's just one piece of a puzzle which is now complete, which explains something. But there are many pieces all around which we don't understand, and we have no clue whatsoever at present. There are many different theories, many had to be discarded because simply the data we have taken are not confirming these type of models. Or at least, if there are, many models exist, at least the limits have been pushed very, very far. And this is something which is indeed puzzling us as physicists, what is going on. Great theorists have said, after the LHC turned on and first discoveries have been made, because no new particles have been seen, well, we are not yet in despair, but we are disappointed. But somehow, with time, the despair is going on because of the lack of finding other new particles. So, indeed, we are left with something very puzzling. The Higgs boson is surprisingly light. There's no evidence for other particles. And a large difference in energy scale is there, which was not really expected. And therefore, we refer to this as what we call, as physicists, the naturalness problem. And I would like to use this to just point again to naturalism versus supernaturalism in relation to this fact. Because there are no new particles which have been seen so far, which go beyond our standard model, nor has any mechanism been observed to explain why the standard model parameters happen to have precisely the values which they have. And the results we obtained so far with the LHC made the case for naturalness definitely weaker and for fine-tuning much stronger. And the question which we can ask ourselves, how much fine-tuning are we ready to swallow before we give completely up on naturalness, or let's say natural explanations why parameters have the values they do have. Yeah. And if there is fine-tuning and things point in that direction, then of course the question is, who tuned the parameters? That is why agnostic researcher is oftentimes not really at ease with this idea, because fine-tuning is not really what people were looking for, but much more trying to find natural explanations to understand why the universe is as it is. Time is running, so I will be brief on that, but it's interesting that we can test the standard model to high precision. We use sometimes very rare processes in order to understand it better, and interestingly, new particles have not been seen. Now I go a bit fast here, but we look at very, very rare processes and try to find very rare decays. Sorry, I went a bit too fast here. I just want to point to this number. There are decays which happen only one time in 1 billion or 10 billion. Yeah, these are pretty big numbers. When I talk to pupils at school, I use the illustration. Imagine a big stadium you fill with grains of rice. You might be able to put 10 billion grains of rice inside, and then they are in total only 1 or 10 which are marked with a red line. Let's take this illustration like that. The challenge we have then is to find these few grains of rice which are specially marked. Yeah, that is just to illustrate the numbers I showed you, 1 or 3 and 1 or 10 billion. And interestingly, we are able to find these 10 grains which are marked. So our data acquisition system and then analysis methods we are using allow us to find these. Here you see a measurement result, the black point, which is in perfect agreement indeed with a theoretical prediction, which is also very interesting if you think about it, that you can calculate processes, give the probability with which it should happen, do a measurement, confirm it really precisely, it's another illustration that indeed what we are doing confirms the intelligibility of the universe. That, yeah, you have the possibility to do such type of measurements and indeed do them with very, very high precision. Now, this is what I would like to underline here. Simply, we can understand the physical world around us to an amazing level of detail and precision. And I would like to mention again, this is only possible really because there is law and order. The universe is, we can understand things, but you can have only intelligibility in an effect if you have intelligence in the first place. If you don't have intelligence at the beginning, you can't have intelligibility and the ability to do measurements as we see them. Okay, now just leave a bit physics behind and very briefly I go to another field in which I'm not expert and not researcher, so I want to state it from the beginning, but I just want not to stay completely only in physics research, but go a little bit to other fields just to indicate that the situation is pretty similar. And here just a few words about chemical evolution and steps towards life. This is how scientists think about it, very simply illustrated from the primitive atmosphere with these elements like methane and water and carbon dioxide and carbon monoxide and others. You get finally to amino acids, then you get to these macromolecules with peptides, proteins, and what is shown there, the DNA, these huge macromolecules, and then you move on to the cell. Now, these are these steps in relation to biogenesis, and just for the formation of macromolecules, you need to make these long chains, as it is shown here on the left-hand side. And this is a simple illustration just to point out that at the beginning you have all these different elements, yeah, shown here in different colors, but in order to make these long chains of molecules, you must actually have two possibilities of a peptide bond. Yeah? What is shown here in green and in yellow and in blue allows to form a chain. Whenever you have something marked in red, then if it comes, as you see on the bottom there, it's immediately an end. You cannot form any longer a long chain, a macromolecule. And this is actually a problem because in the primeval soup, you have mainly molecules with only one bond or a partial double bond. And therefore only short closed chains can be formed, but not the very long ones. So this is really a big problem in relation to the biogenesis or the formation of these macromolecules and finally formation of DNA. But it is necessary for living beings, but it's basically impossible, and here I give you the probability to form a short chain of 100 amino acids. So you have there all these different amino acids, but in order to have 100 together, the probability is given there. It turns out to be 1 in 10 to the 30, which, yeah, you could also say is impossible. DNA is this impressive, very long, more than a macromolecule, and it's like a computer program indeed, and we have of them in our bodies 10 to 100 trillion, and the information in each of them correspond to 3.5 billion letters. The actual length actually of the DNA is 2 meters in the human body. If you would open it, this double helix, but it is really impressive. And you see, as research advances and people discovered it and could analyze it, you get always more amazed. It is widely accepted now that the living cell is an information processing machine. Living things are instructed by genetic software encoded in DNA, and it is not yet even life, it's just all the information which is needed prior to life. These statements have been made by scientists like Werner Löwenstein. This genetic lexicon goes back a long, long way. Not an iota seems to have changed over 2 billion years. It's really impressive. All living beings on Earth, from bacteria to humans, use the same 64-word code, and then in this long chain. Sir Fred Hall said, if one proceeds directly and straightforwardly in this matter without being deflected by a fear of incurring the wrath of the scientific opinion, one arrives at the conclusion that biomaterials with their amazing measure of order must be the outcome of intelligent design. No other possibility I've been able to think of. Now, later on he proposed also that somehow a spaceship must have brought it to planet Earth, because otherwise he couldn't explain how it could arrive here. And of course there are better explanations if we believe in a creator. So where does the evidence lead? I conclude that part with this statement of Richard Jastrow, an agnostic, and he was director of NASA in the past many years ago. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountain of ignorance. He is about to conquer the highest peak as he pulls himself over the final rock, and he is greeted by a band of theologians who have been sitting there for centuries, having somehow the answer, because yes, they started with the assumption there must be a creator. Information and intelligence are fundamental to the existence of the universe and life, and far from being the end products of an unguided natural process, starting with energy and matter, they were involved from the very beginning. And indeed, in the beginning was, Hans von Baer stated in The New Scientist already 18 years ago, in the beginning was a bit to emphasize there was information, which is interesting in the light of what the Gospel of John states. In the beginning was the Word, and it states as well, all things were made by him, the Word, and without him was not anything that was made. But then the message goes on. God revealed himself to us, and the Word became flesh and dwelt among us, full of grace and truth. And it's nice to see the link which is made immediately there between, on one hand, the creative power of God, and on the other hand, that the Word became flesh. Now, in the last minutes, a few more remarks, just taking the message a bit further and apply it also to us. The Bible reveals to us Jesus as a creator of the universe who is in control of the universe. But he invites us not only to believe certain facts, but to trust him, so that we can experience the wonder of receiving a new kind of life that Jesus himself called eternal life. Again, I quote here from John's Gospel, the verse I have mentioned already earlier, that what is written that we may believe that Jesus is the Christ, the Son of God, and that believing we might have life in his name. And the Bible promises to those who believe in Jesus a personal living relationship with God, which is possible through him. This is eternal life. We read in John's Gospel that they know you, the only true God, and Jesus Christ, whom you have sent. But you see that that is really the message and the invitation which is there to come into a personal relation with God Himself. Once we begin to talk about personal relationship, clearly we leave, strictly speaking, science behind us, but I want to emphasize again, we don't leave rationality behind us. There is this difference between scientific knowledge and personal knowledge. And it's nice to acquire scientific knowledge, but it is more to have personal knowledge. And this we know from our life as humans, because indeed we relate to each other and we are able to know each other, and normally we do so in speaking to each other and making ourselves known to others. But what is true for human relations is also true regarding the relation we can have with God. The central claim of the Bible is indeed that God has spoken. He has revealed something of His glory in the splendor of the universe. And even if you look at the microcosm, we see something of it. But also He revealed Himself to us in what we read in the Bible, and finally He has spoken to us in His Son, as we read in Hebrews chapter 1, that God has spoken to us in the Son. And the central message we have then in the Bible is that He, Jesus Christ, the Son of Man, He did not come to be served, but to serve and to give His life a ransom for many. And I really want to come to the core of the message of the Bible here, and also to what we read in Luke's Gospel, that Christ, that it is written, should suffer and rise again from the dead the third day, that repentance and remission of sins should be preached in His name to all the nations. To go a little further in relation to the message of the Bible, yes, it tells us who we are. It reveals to us that man is a created being, man is a spiritual being, man is a rational being, but also a moral being. That is how God has created us. But we now, as we look at how man has been created, something changed. And we have to admit there is a brokenness in relation to man. There is a brokenness in relation to people in general, but we see it also in ourselves. At least if we are honest about ourselves, acknowledge this brokenness, which the Bible indeed calls sin. Now, the message of the Bible tells us something about Christianity, and it is not just offering us a realistic diagnosis of the problem which is there with man, but also talks about the remedy. And this remedy is really there to offer a new, satisfying and meaningful life. Now you might say, well, you talk about Christianity, what about other religions? And here I just want to emphasize that the message of Christianity is very different from the message of world religions. Some people say that religions are all fundamentally the same, superficially different. But if you look more carefully, you see that they are fundamentally different. And only a superficial look tells you that they are the same. What are the main differences? First of all, that in Christianity we don't find a merit-based acceptance by God at the final judgment. Not that my good works eventually should outweigh my bad works and based on this I might be received. It's not like that. But it tells us that we can be accepted by God at the beginning, just recognizing who we are and accepting what Jesus Christ has done. As many, we read in John chapter 1, as received him, to them he gave the right to become children of God, even to those who believe in his name. Now, I come to the end. In science, the testing of new ideas and theories plays an important role. But contrary to what many people say, Christianity is also testable. And this not only in a general way, the statements made in the Bible, but also testable on a personal level. Jesus promises to those who repent of their sin and trust him for salvation, peace with God, forgiveness, new life, new desires, but also resources to cope with life's pain and suffering. And one could have added many more things in relation to what the Bible really offers and what the believer in Jesus Christ receives. The Greek word from which skepticism is derived means to check out from a distance. I find this very interesting, and it's important to do that. You don't buy into something without checking it first from a distance. It's important, and that is what we do. But there comes a point when we have to give up that distance in order to make progress. And this is what I would like to emphasize at the end. In order to gain final evidence of the truth of Christianity, we have to make that step. Give up the distance and really repent and trust in Jesus Christ. That is needed in order to be really convinced and gain the final evidence of the truth of Christianity. Now, is there still a need for God? That's a question we asked at the beginning. And I hope I could show you that from various viewpoints, indeed, there is this need for God. Not just to understand the universe in which we are living, but beyond that, in order to really come to a meaningful life. All this is offered to us in relation to the message we find in the Bible. And with this, I would like to close and really emphasize again this invitation to take the message of the Bible serious. Read it, read John's Gospel, for example, in order really to get personally this conviction about the truth of the message. Thank you very much.